So yeah, the dark side of microservices. I realize that sounds quite dramatic, but it's more generally talking about microservices. So there's a lot of information out there, like what it is and like what the great things are about it. But there's not like a lot of information out there how much effort it actually costs and like what that actually does to your business. So I'm going to like give you a brief overview of that and like how we tackle that at my company. And I'm going to like before I get into that, I'll give you a little introduction to like what we faced, the issues we faced, and what I do there. So who am I? I'm Jelmer Snoeck. You can find me like this on the internet. And I managed to get a fancy job title. It's called Platform Reliability Engineer. But it's basically based on Google's SRE book, Site Reliability Engineering. And what I basically do is I provide a tooling for our engineers to actually build all these microservices. And once they've built them, I help them make them performant, reliable, and scalable, basically. And all of that I do at Lost My Name. So Lost My Name is a Google Ventures-backed startup based in London, like 10 minutes from here, actually. We got roughly 30 engineers, and what we do is we combine engineering with storytelling and for digital and print. So we actually make books and posters and like all of that. And we're best known for our first book, which is The Little Boy or Girl Who Lost His or Her Name. And we launched this book in 2014. And it's been one of the best-selling pictures books in like the last few years. It's very popular in the UK for people who are from the UK. But we also have a second book, The Journey Home, and this is going to be like the main topic of this talk. Like the examples are going to come from that. And this book is basically all about space. And we launched this book 2015, like a little bit less than a year ago. And it's basically the journey back from space to your home for the kids. So they call like the experience of being in space and going back home. Fun fact about this, we actually managed to launch this book into space. Astronaut Tim Peake read this book to a kid. It's like they won a raffle. So at the moment, this book is like 250 miles up in the air, orbiting the Earth at like 17,000 miles per hour. And all these books, we actually create them on demand. So every book is unique. So you go on the website, you put your name in, you put your diversity in, you put your gender in, and all those things. You also put your address in for the second book. And then we create a preview on demand for you, and we print that on demand for you. And last year we sold a little bit over 1 million of these books. Last year we also noticed a lot of issues because like it was our biggest year because every year you grow, and we started to like notice that our system is like starting to like fall apart a bit. And the main reason was we got basically two different stacks. This is not an actual representation of our stacks, but like it's close to it. And we were seeing that there's a lot of maintenance issues, and no one really knew how it worked because like we had to go from one team to another team, and no one really takes ownership of anything either. So we had like a lot of organizational issues with these two different stacks. And out of these two different stacks also came the issue that for the second book, we didn't have a preview. So for the first book, we had a preview, which looks like this. So that means that you can go on the website and actually like flick through the book and see what it does. And it's like a great thing because like no one really wants to buy a book and not look at it for £20, right? And the reason that we didn't have that for the second book is that in the beginning, we actually made PDFs for the second book, and extracting images out of the PDF was like quite complex to do it in like preview time. But the second book is also quite complex in itself, and this is an example for it. So what we do with the address, so this is a service that we call Landmarks, and it basically it takes your address and it goes to the database. It looks up like the closest famous landmark. So if you live in London, you got like these landmarks, and then it's going to put that in the book. Another one is this, where it like takes your address. It basically goes to like an API, gets like the satellite images from it, and it puts that in the book as well. And we have to do that for every request. Like every person that comes on the website, we have to do this. And for like this is all third-party integration, and a lot of these third-party integrations don't allow us to actually cache these things. So we weren't able to do that. And this is where we came up with the platform. We wanted to tackle these issues. Another thing we wanted to do is like all the cool companies have platforms now, so we thought like why not have a platform to do this? And as a seasonal company, we kind of have luxury. So this is basically traffic to our website. And like you can see, oh, you can't really see it. But like the last bit of the year, we basically got like a massive spike, and then it drops. And then for the first like 6 months of the year, we don't really have that much traffic again. And that repeats itself every year. And that's like actually quite like luxury that we have, because we got basically 6 months to build something and then release it for big audiences. But if you tackle a project like that, you got to set yourself some goals, right? So you got to set yourself some goals to actually like say, oh, we actually delivered on this project. We actually did a good job. So we set ourselves some goals, and the interesting thing, like the important thing to actually think about this when you do this, you actually have to like work with the business yourself. Like you set development goals, which are like all the cool stuff you want to do, like Kubernetes and all that stuff. But you also have like the business goals, which are like bring in money and actually pay your salary. So you have to like, it's up to you and like up to your team to actually find a balance between those things and actually like make sure that works. And that's often overlooked, and we saw that in the beginning as well. Like we did a lot of that stuff. Like we tried to like move fast, but then we couldn't really deliver on those things. So it's important to think about that. And this is like a small list that we came up with of things that we need to do. So the first thing is preview. This is the preview of the second book, so we actually delivered on that goal. And it's like a massive selling point. Like we A/B tested that. The thing is, like this needs to be super fast. It's not that high resolution because we don't want to expose the books to the people so they can print them themselves, obviously. But it's like high throughput as well, like 350 to 400 previews per second, basically. And on the other side of that, there's print. Print is very high resolution. It's like over 20 megapixels per page. But it's not on demand, so we got a little bit of grace period, and it's not that, the throughput is not that high as well. It's roughly like 10 to 20 books per second. And all of that you want obviously to be reliable as well. If you look at our sales graph, basically the last 3 months of the year, we basically sell more than we actually do the rest of the year combined. So if we lose previews, that actually means that we lose a lot of customers. But if we lose prints, that means that the print houses get like backed up, like they have to like print a lot of delayed prints. And that means that people can't get their gifts. And imagine that your kid can't get like his Christmas gift. That would be pretty bad. So yeah, it all has to be very reliable as well. Another thing that we really wanted is it needs to be language agnostic. So this is a service we call Name in the Stars. So what it basically does, it takes a string of text and it converts it to a galaxy created, and it just like prints out the string of text like in stars. And all of that is actually done in like a completely different architecture, but like it's running on a GPU box and like written in C++. So we need to like be able to like hook that in, because we got creatives that actually do all these things, and we can't like limit their creativity with that. The next thing is, this is the same service, so it's like, we need to make it all reusable. So this is the same service, but in a different composition, basically. So what we did is for Christmas, everyone who bought Journey Home book, we actually sent them a Christmas card with their name on. So we definitely want to reuse these things and make it easy to like reuse all these things. So I mentioned several services now already, and that brings us to microservices. Like we saw that we organically were growing to like multiple services, and like just every now and again, like something new popped up. Like marketing made something new, the designers wanted something new, so the creatives made something new as well. So like we came across this, and like a lot, like there's so much talk about microservices nowadays. Like even in this conference, there's like I think 4 talks, including mine, about it. It's actually not something new. It's like just a new label that people put on it. What we wanted to do is like, if you think back about the diagram I showed you, we just wanted to streamline our whole architecture, and that was the goal with this whole platform, basically. So what we did is like we went to the internet, which is like the truth always. Like everything on there is like correct. So we looked up what microservices actually promises, and like if you read a lot, like the blog posts mention these things a lot. Like by default, it's like fault tolerant. Like if something goes down, you got other nodes that you can just like pick up on. It's easy for development. You just like spin up containers and like you can use those containers in development in production as well. It's like exactly the same. It's language agnostic. Like it's just an API, so you don't really have to like bother with anything else. And scaling, like if one service needs more scale, you just like crank that one up a bit, and that's it. So we were like super happy with that. It's like a perfect match. Like let's do this, right? Or maybe not. So we're a relatively young team at the company. We don't really have any experience with all of this. And if anyone went to Peter's talk on yesterday morning, there's like so many things that you have to think about. Like he mentioned that there's 40 things that for every service you have to think about. So there's like communication, discovery, testing, how you're going to deploy all that, how you're going to monitor all of that. And you got to think about that per service now, basically, instead of one big application. So the first thing we did is we looked at the framework. And with a framework, I don't really mean like the code framework, but more like the structure, more like the architecture in general. And we wondered, like, we asked ourselves, what are we going to use? Because, like, if you like look at all these blog posts about microservices, like, there's like all these terms that they throw out. So, are you going to use REST or RPC? Are you going to use HTTP or a message bus? Are you going to use JSON or protobuf? Or containers or VMs? And we were honest with ourselves. Like, we never use protobuf, we never use containers. So we're like, we have no idea what is the best, right? So we went out and we started looking at these toolkits. There's like a list of toolkits that we looked at. We also considered writing our own, but that was like in the garbage can for like after like 2 minutes. Because like we didn't really want to do that. And in the end, we ended up with Go Micro. Asim is actually giving a talk about this later on, so if you're interested, definitely go check that out. And we chose that because it's very easy to start with. It got us like up and running like really quickly, and it's basically full stack. So it has like a lot of functionality built in. The issues with Go Micro at that time though was it's very young. So we were speaking with Asim, it's like no one really running this in production yet. So it wasn't battle tested. So we didn't really know if it's going to take our load or not. But that's a risk we were like happy to take because like it got us up running so quickly. And we actually could deliver some like premature like little things that we could show to the business. So that was cool. But on top of Go Micro, we actually built Golem as well. And that's like basically like Twitter's Finnegal or Netflix Carrion. I don't know how you pronounce that. But it's basically doing all the configuration and the setup. So if you like 3 retries or whatever, or like extra wrappers and stuff like that. But it's also a bit like for everyone who works with Rails, it's also like Rails. So if you do Golem new and you set Golem new in the service name, it's going to set up a project locally, but it's also going to set up GitHub. It's also going to set up Travis. It's also going to set up logging. It's going to basically take those 40 things that you have to do per service. It's going to take a whole bunch of those and already like do that. And it's also doing some extra functionality or extending some functionality from Micro. But with Go Micro, we actually lost one big benefit. And that's language agnostic. If you think about in that list before, we got gRPC as well, and that actually compiles to like different languages. There's like, but this is just like a little bit of them. There's I think 12 by now. And that's all great that it does that. It's like a big selling point for microservices as well. But the biggest benefit, the biggest thing that you actually lose with using multiple languages is that you have to like do all that bootstrapping or the setting and configuration all over and over and over again per language that you do. But you also lose, the most important thing in my opinion is that you lose like knowledge about the language itself. Like you need basically a specialist in every language to actually make a really like optimized like service or system across all these languages. So cool. You know how all of that works. You know you're ready to like actually start building things, right? You're able to like create services. You like just pump them out, like you start like just making them, and then you like decide, oh, I actually want to use that other service that I wrote to actually like use in my service because I'm not going to duplicate it. But how do I communicate? And this is where service discovery comes in. So service discovery just like as a service discovery system to like give a list of nodes that's healthy, and just it gives you back a list of IPs. And this is like a few service discovery systems that there are. There's more than this. We didn't really look into any of these, apart from one, which is console. And the only reason we did that is because it's the default for Go Micro. Like, we didn't really want to put too much effort in it. We saw that it like gave us what we wanted. It might not be the best, but that's probably issues for later on then. And delivered, like, basically delivered our goals. We were able to like make sure that our product was out there. The important thing to know is we didn't convert everything to this as well. Like, we still got a lot of stuff behind ELBs and like other load balancers. So it's like, it's okay if you don't migrate everything to this immediately. The next thing we looked at is, I can't see, well, everyone probably recognizes the logo anyway, is containers. So containers is like the next big thing, like if you look on Hacker News and all that stuff. So every blog post you read about like microservices mentions, oh, you need to use containers, right? You need to use Docker, you need to use Kubernetes and all that stuff. But we asked ourselves, like, we got this whole architecture, like this legacy architecture already deployed and like up and running. Like, what value is it giving to us? Like, we're using Chef internally. Like, is this going to like bring us so much more value? And is it really worth it? And we decided it's not. Like, don't get me wrong, containers are great, and we're actually using them in some new projects. But at the time, it was like, we found out it was too early. We had other priorities, like one of them was automating our system so we could like replicate our environments with Ansible. And we just didn't feel like it was like good enough at that time. This was 10 months ago. Good enough at that time to actually like invest time in it. The next step that we looked at is orchestration, right? If you come from like Docker, you immediately start like looking at like how are you gonna like deploy all these things? Like, you got this running locally, like how are you gonna get this to customers, right? One solution is Kubernetes, for example. More recently, also Docker Swarm is like integrated in Docker itself now. That's like, it's just like a proof that, or reasoning behind not going for Docker yet was it wasn't mature enough yet. Like, there were still a lot of changes, and like 3 months later, they actually put Docker Swarm in Docker, and that's like just an example of it. So we couldn't use all of these because we had our own legacy code with Chef. So we actually like built a really small version. It's like we built this in 2 days. It's like nothing special, but just to show like you need to have like, you want to support your legacy, but you also want to like make it easy for yourself to like get out there. And like the downside of this, everything is like on a single box. Like, we don't have orchestration at all. It's just like a single box per service. And it doesn't, like, you can't schedule anything either, or it doesn't like auto scale or whatever. So cool. Again, like, you're a step further. You know how to build all these things. You know how to communicate between these things, and you know how to deploy all these things. So actually, like, you get some customers. So actually get some customers, and you actually like put this out, and like you get traffic, and you're super happy. Everything's green. Like, you built all these dashboards. Like, it's great. And all of a sudden, like, this is starting to happen, and then this is your reaction. Like, what's going on? Like, I got 50 services, but like, which one is failing, right? How are you going to track this down? And this is where tooling comes in. So my part of like at the company is actually like to provide all this like reliability stuff and like be able to like, if there's an issue, like immediately like dig into it. And because it's my task, and like this is a piece that we didn't compromise on. We were like, this really needs to get in from the beginning. And for the company, this doesn't really look important, right? Because like this is not giving them money. It's actually costing them money because like, we use external services to actually like store data and stuff like that. But from a dev point of view, this is very important. So you definitely have to like try and get this in as early as possible. I'm just going to go over like 3 main topics here, just to give you a little example. But what you definitely have to remember is you need to make all these tooling things very easy for the devs to use, right? You don't want to have to go to like your devs to like 3 different steps to actually like do something and like get metrics out. Like, you don't want them to like have to like think about all these things. You just want them to be able to use it. So that's again why we built Golem. That's like the extra functionality that's like built into Golem for us. The first one is metrics. Can can't really see it, but like we got a lot of metrics. Like we use, so we write all the metrics to statsd, then Telegraph picks that up and puts it in InfluxDB, and then like we visualize it in Grafana. It's like 3 dashboards you can see here, but we got a lot of these. And it's cool to have all these dashboards, right? That way you can like put up like a big TV, like put the dashboard up, and like, oh, your boss is like, oh, everything's green, great. But it's very important to actually have like the correct metrics as well. This is just an example. It's like an experimental package, so it's for people who are used to Ruby. GitHub Scientist is basically a copy of that. So you can like run 2 code bases against each other and see which one is like quick and like which one is slow and like error rates. But if you look here on the left side, there's like, well, you can't really see it here, but these are all blue lines. On the left side, that's missing. But what is here, which you can absolutely not see, there's like some red lines and some yellow lines, and that means the controller is erroring or the test is erroring. But that doesn't really give you that much information, because if the controller is running like, if there's an error, like 3 errors, but the test is running 1,000 times, that's like not that much, like not that relevant. But if the test is only running 3 times and you got 3 errors, that's like quite important to know, right? So another thing that you can't really see is like there's like a tiny little red line here, and that actually marks deploys for us. And what that is helpful for is if you look at the line here, all of a sudden the blue lines start to appear, and that actually means that we deploy the service, and actually that fixed that data, the missing data, and all of a sudden that's in there. And the cool thing about that is if you look the graph above, we also saw, so the predicted behavior for this test was that the yellow line would be would be quicker or like lower than the green line. But if you look here, it's all above it. But all of a sudden, like we deployed the actual cache implementation, and all of a sudden it was quicker, well, most of the times. And it's important to have that in place and like, be able to like immediately spot what you need to see. Like you can build as many dashboards as you want. If you don't have the right ones, you're never going to be able to like figure out what's wrong. Next up is distributed tracing. We actually built our system according to like the Google Dapper paper. We spent a lot of time in that because we really thought it was very important, and we use it a lot for debugging and originating errors and stuff like that. This is what you can do with it. I think Peter mentioned this as well in his talk yesterday. You got like Twitter Zipkin, there's like other solutions for this as well. So what you can do is like you look at the full request, which is like taking 112 milliseconds, and then you look down and you see that there's one that is taking like 95 milliseconds. And you can look at all of that in numbers, but like what Dave mentioned as well earlier, a visualization is sometimes easier to look at. And if you look at this, you can immediately see that like there's one big chunk that is actually taking a lot of time. So you can dig into that and actually like start optimizing that. Another cool thing with distributed tracing is that you got trace IDs. So what it actually does is you start a request, and for every service it touches, you're going to see a trace ID. And like what you can do with that is put that trace ID in logs. And then you can like start measuring that. I'll show you that in a bit. So logging is another very important bit. A little bit of side note, I don't believe in log levels. Someone else mentioned it, I don't remember who it was. But basically, if you need logs in development, you kind of need them in production as well. If you have an issue in development that you want to debug, you put a log line in to debug it, then you remove it, or like you don't log it in production, like why did you put it there? You kind of put it there to actually like debug. So if that issue actually happens in production, you want to know about it, and you want to know all the data that is related to that. So logging is like, it's been like a common thing to solve, and there's actually a talk after this about logging as well. But what I definitely want to have you do is think about having everything in one dashboard and make it searchable. And if you think back to the distributed tracing that I showed you earlier, then you can basically do things like this. So in the right column, we basically have a trace ID. So every API call returns a trace ID as well for us. So, and if there's an error, we actually log that as well, like in our reporting system. So what happens then is if you have that trace ID, you can just like look up that trace ID in the logs, and then you also see all the you can see all the services as well that touch that trace ID, right? And then you can immediately start like digging into where the error actually is coming from. And that's pretty cool, and that's pretty handy, because like if something happens, you want to be on top of it like immediately. Because if you got like 5,000 requests per second going through, you're going to have a lot of logs, and if you have to like match the timestamps, that's just not going to work. So what I want you to do is basically think about your business, right? Think about what is going to give you the biggest value. And just to give you a few examples, we didn't use containers, for example, because we thought it was too early. And we had other stuff that we wanted to do that was going to give us more value. We didn't really want to do orchestration either yet, because we didn't have the tools for it. But we decided to build a little bit of visualization on top of that with Chef, like our existing infrastructure. And then tooling, for us, that was very important, so we didn't want to compromise on that at all. Like, that was a must-have. We gave like a little bit of slack on the other things already, so we were like, really, like, this needs to go in. But most importantly, you got to set your own priorities, right? You got to ask yourself the questions like, do you really need this architecture? Do you really need like these microservices? Like, we grew into this like kind of organically, but do you really need this? Are you willing to pay that upfront cost that you have to like set up? And it's basically up to you. And some things you need from the beginning, and some things you don't. But in the long term, you need to like make sure your business works, and yeah, because they keep paying your salaries, and you got to think about that. Thanks. That's it.
Thank you very much. So if you had to do it all over again, would you